is that you have to learn, each side has to learn a bit the basic parts, not complete, but basic parts of the language of the others, that we really can communicate and that they can tell what are their real problems.
比如说可以从黄大年开始，你比如黄大年可以提供一系列的数学的课程，比如说是一些跟那个 AI 相关的数学，或者说跟其他方面，跟研究物理、跟材料化学都需要不同的数学。从最简单的方程式开始，慢慢一步步的把这个问题给解剖开来，往深的方向走。就看你的兴趣，觉得要有一个好的一个提供知识的平台，我觉得需要形成一个这样的机制。数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. For some things it's like art. If we think about everything which surrounds us, the technology, the laws of physics that describe what happens in nature, we can use them, we can do something with them. We have the technology that we have because there is mathematics. Mathematics has been the way for the human to understand phenomena.
That in fact, by now there are in fact many parts of mathematics which have become interesting for applications. So many more than a few decades ago.
应用往往是一门综合学科 ，even 在数学里面，你要解决一个应用数学解决问题，你不是一个单门的理论数学可以解决，这实际上是一个系统工程，数学的系统工程。
So we are at a moment where I think the computational power, it's really at the maximal level, maybe a bit better, but nothing exceptional. It's not going to be like 1,000 times better. But mathematically, as I say, there are many challenges, and I think once we will understand better how AI works, why it works, how to improve it, how to make it more efficient, safer, and everything, this is when we will see a next revolution.
I mean, if you have theory but without practical case, so you find, you kind of lose a sense of purpose. Whereas, here, if you do also the practice but without a good theory, well, you will continue on improving already known techniques, but you will not do something revolutionary. I mean, of course, you will advance the technology, but basically you will be in the same trend. I mean, we'll just add some new layer of refinement, but it will not be a step forward somehow.
So we think that, of course, when you are a theoretician, you are looking for understanding. But when you are an engineer, you are looking for something which works better. But then there is a miracle that usually when you get better understanding, you become more efficient. So here what we need is in some sense to enrich the amount of mathematical knowledge of the computer scientists we talk with in order to make them realize that they can try to implement larger schemes.
就比如说是像那个大型语言模型，它里面最基础的模块是 transformer。transformer 实际上基本来说90%以上都是矩阵运算。这些矩阵运算我们如何给它加速？如果说我们能够加进很多数学的东西，就比如说利用好的矩阵分解、张量分解，利用比较好的核函数的设计，以及利用比较好的那个位置编码的方式，我相信是可以更有效的去加速整个大型语言模型的计算。
I studied mathematics. I developed new methods for solar physics. And then during conferences, I met people from cardiology. They showed their time series, their measurements, and looked very similar as solar activity. And then this is a way of interdisciplinary. Then we talked with each other and worked with each other. But the important point is each discipline has its own language, specific language. And the problem is that you have to learn, each side has to learn a bit the basic parts, not complete, but basic parts of the language of the others, that we really can communicate and that they can tell what are their real problems.
比如说可以从黄大年开始。
So, you, as ICPC participants, you solve hard problems, right? You do that here at competitions, and you also do that out in the industry. And we at JetBrains, we want to help you with that, right? If you are the engine of innovation, then we want to be your catalyst. We want to make sure that you are great at what you do. So, with algorithmic problems, there's no questions, you're the creme de la creme. But in software engineering out in the industry, there's a lot of tasks that are also involved. And we think that both our tools, but also our new AI integrations can really help you excel in all of those as well, and just make you more productive. This entire story starts for us with JetBrains Juni, which is our coding agent that we've built for you. You've probably heard a whole bunch of things about coding agents in the last couple of months, so what makes Juni special? Well, it's agentic AI that meets world-class tooling. Juni answers your questions if you're exploring large code bases, it writes code for you, but it can also do things like restructure code. It can help you with refactorings if you're working in systems. It can help you understand large code bases and navigate them well. And it also, as we'll see in a little bit, refines those implementations. If I could get someone from the video team to put my slides up on my screen in front of me, then I can also keep a little bit of eye contact with people. It's available in the JetBrains IDEs that we have up here and a couple of other ones that are still coming up, and it's ready for you to use. Now, I don't want to spend too much time with all of you looking at the interface because, you know, it's a text box. What I actually kind of want to draw your attention to is what's around it. It's the fact that it's integrated inside of the IDE. And this isn't just a vanity thing, there's a reason why this matters. Because as it turns out, JetBrains tools have empowered developers for over 2 decades now. And the same kind of things also help empower AI and take it to a different level. You'll see this when you start Juni with some kind of prompt. First of all, it starts planning out what it's supposed to do. But then it approaches the actual solution in a way that's very similar to how you would do that as well. So rather than just ingesting the entire code that's in your code base, it actually looks at, for example, just the structure, high-level definitions, what symbols are actually relevant, what actually matters. And then when it makes changes, it realizes when it makes mistakes. Why? Because it sees the same warnings, it sees the same deterministic inspections that we've built for the last 2 decades, and we feed those back to Juni, so it can actually make those changes in much fewer iterations. When you have tests in your project, they are automatically run as well, which means that once again, you get the deterministic side of things integrated with the part of automatic generations. And of course, it uses all the infrastructure that's already available and tried and tested inside of our IDE. So this works really, really well. One of my favorite features of Juni is that when you ask it something and it's not sure where it's supposed to go, rather than just go full sprint into a random direction, it actually asks you a question. It asks you to clarify. So you, as the people who are solving the problem, the core issue, you stay in control. We're not trying to take that away from you. We're trying to empower you. Of course, since we're using a bunch of different models under the hood, it's also really nice that Juni is multimodal. It's not just a text box, it's this universal drop zone thing. So even someone like me with very terrible artistic skills can draw up some kind of UI diagram, drag that in there, and just a couple of minutes later have a fully working implementation that's based on exactly the specification that I gave. That just makes life a little bit easier. It's all of these things together, these integrations that you get out of the box that make Juni truly world-class. It's a superpower in its sense, right? Running tests, like automatically course correcting. The fact that it can navigate even large code bases and even match patterns, right? You'll find very quickly that when you try Juni yourself, it writes code that looks very similar to all the other code that's already existing in the code base. So it's not trying to take the shortest path, it's trying to take a really good path. And of course, while you do all this, you stay on the driver's seat. These are all the integrations you get out of the box, but of course, if there's external services, you can integrate it using MCP, using the Model Context Protocol. You can plug those in, either to have Juni interact with things that are out there, so it can, write a comment on your GitHub issues, but you can also just feed it additional information. So if you have internal knowledge sources, Juni can automatically pull these in as it works for you. And of course, the best part is that you can use it today. We already have it in a bunch of our IDEs, and one of the IDEs that you're probably most familiar with, C-Line, our C and C++ IDE, is getting support for Juni this month. You, as contestants in the ICPC World Finals, also get JetBrains AI Ultimate, which is our highest usage tier of our AI tooling, for free. You already have the information on how to actually access this in your inbox, so later on, you can just check that out. It's not actually just Juni that's integrated with this, but it's also AI Assistant, which is all the integrations that are baked right into the IDE. There's a lot of small things that I don't want to shout out too directly, but you have things like commit message generation, test generation, and so on. But it also comes with full-line code completion and multi-line code completion, which are very exciting, first of all, because it's quite convenient, but more importantly, because of the technology that underlies it. Because our code completion technology is actually based on Melum, which is a language model that we've developed inside JetBrains and then decided to open source. So it's actually something you can play with. Interestingly enough, you'll notice here that on our Hugging Face page where you can download it, Melum is a 4B model, so it's a very small model. It's not a typical large language model. The reason for this is because rather than being a generalist, it really excels at one specific thing, which is code completion. So that's why we call it a focal model. It really has focus on one specific task, code completion, including fill in the middle, where it looks at a larger code snippet and can even fill in parts that are surrounded by code. So even if you don't have a spare $1 million to rent a GPU cluster, there's a good chance that you can actually make a fine tune of this and try this kind of tech stack yourself on your own machine. AI Assistant is available in our entire suite of JetBrains IDEs. And we give you access both as you as students, or if you're in a teaching role, we give you access to the entire breadth of our offering through our student and teacher packs. So you can just sign up there using your university email address, and you'll get access to everything. The core thing that's probably most interesting for you is C-Lion. Once more, it's getting Juni support later this year, but it's probably interesting because if you look to your left or to your right, statistically, probably there sits someone there who might be using C-Lion, because 1/3 of the teams in Astana during the World Finals actually used C-Lion, which is also just really exciting for us. So a big thank you to all the C-Lion users out there. We're glad that we can build tools that empower you. At all ICPC competitions, both C-Lion, IntelliJ, and PyCharm are available for your competition needs. Now, I have a tiny bit of a personal request, because you do solve hard problems. And as you can maybe see, I'm a little Kotlin branded here, so I would really encourage you, maybe sometime, try solving some problems in Kotlin. You might find it quite fun. We're running the Kotlin Heroes contest on Codeforces, with the practice round actually opening today and then the actual contest happening in 10 days. So if that is something that you would like to join, please do. It's very, very exciting. You can get some fun prizes. So yeah, check that out as well. Because Kotlin isn't a language that's specific for mobile. It's a language that really moves the world nowadays. If you're in a car and you're interacting with the infotainment system, if you're on the New York metro system and you are tapping your card, if you're on an airplane watching a movie, if you're paying your taxes in Norway, if you are watching the Eurovision Song Contest, if you're getting packages delivered, if you're interfacing with your bank's server systems, or if you're ordering fast food, all of these things, they run through Kotlin. I don't want to spend too much time about the very specific details, but it's really true that Kotlin is a language that's in so many different places. It's not just mobile. If you actually want to learn more, if you want to teach other people more about this, we provide a full curriculum that has all the teaching materials that you need to teach Kotlin in a computer science context. That includes not just slide decks, it also includes all the speaker notes. It includes slides, homeworks, quizzes, tests, all of these things. And we also provide you with an interactive development environment called Kotlin Notebooks, where you can interactively iterate on code quite quickly. And this is all for free to use, to adapt, to change, and to both learn and teach with. So yeah, Kotlin really is a pragmatic language on the server side, on mobile, for desktop development, and of course, it's 2025. It also pairs perfectly with AI. How well does it pair? Well, our friends outside from OpenAI have decided to implement a Java API library. And they did it in Kotlin, which is quite exciting to us. The folks from Anthropic decided to build a Java API library, and they decided to implement it in Kotlin, which is very exciting to us. But of course, those are kind of like on a lower level. Even if you're going all the way up to building agentic systems nowadays, Kotlin is a great choice. Why? Because we have a framework called Coog, which is specifically designed for building even complex and scalable AI agents. It's completely LLM vendor agnostic, so we're not giving you, we're not limiting you on anything here, and it fully manages the LLM interactions, which means that even as you have complex workflows, you can express those very clearly using Kotlin domain-specific languages and express even those graphs in a way that's really easy to still maintain. And what's most important is that this isn't really just for toys, it's also for things that are supposed to scale up, right? So it has things like observability and traceability, it has memory management, you can do history compressions and tons of other things. I don't want to spend too much time for this because we all know why you're here, but I do want you to be aware of this. You can check out coog.ai if you want to learn more. We're here in Baku, and we have a ton of fun activities. So whether it's here at the venue, out at our booth, or back at the hotel in the chill zone, we very much invite you to come talk to us, to come learn about things, but also to participate in our activities, in our challenges. It's going to be a really, really fun time. Speaking of fun, this is the moment that I think we've all been waiting for. We're very, very excited to move on to our programming challenge. And for this, I'm very excited to welcome up to the stage Eknamala and Second Thread. Give them a big hand. Very nice. We'll give our contestants just a couple of seconds here to set up, but to go on over to this time, we had a tiny little challenge. We asked two people, the two people right behind me, and one Junie to implement the following code snippet. Given an array of integers, find a subarray with maximum sum. I'm throwing those up here. They're written in Python because we want you to parse this extremely quickly. So my question is, here are all three of them. First, we're looking at the one at the top left. Who wrote this code? Is it David, Andrew, or Junie? Who thinks this was David? Okay, couple of hands. Who thinks this was Andrew? Okay. Who thinks this was Junie? All right, it was Andrew. Good job. Okay, very good. Well, y'all got one more chance here. This is the decider on the bottom left here. Who do you think wrote this? Was it David? Was it Junie? Okay, that's a pretty even split. This was indeed Junie, and then we have David over on the right. Thank you so much. Okay, great. Then I think we can move on over with the screens, and we can see if our contestants are ready. I can see one screen that looks very well. I can see the other one as well. Quick thumbs up. Everything looking good for you guys?
Yeah, I think we're waiting for the contest to start.
I think it's ready. So why don't we just open the first problem in 3, 2, 1, go.
Spy detected. We have an array of over 3 integers. All the numbers except 1 are the same. We want to print the index of the 11. So
all right, so we can see Andrew on the left here, David on the right. Already a lot of typing going on. So yeah, in case that flashed too briefly for you folks, the contestants did get an array of numbers, and all the numbers except one in that array are the same, and they need to find the element that's different from all the others, and then output its index. I was originally challenged to explain that before they got a solution, so let's see how far they've gotten.
Oh, index, all right.
Hey, look at that.
That makes it harder. I think my mic's on, yeah.
Okay.
All right, so then sorting it is not the way to go.
You can already see that the code takes very different shapes here. Andrew taking a very long approach, but we got a very tall approach over here by David. All right. We're certainly seeing some numbers. We have a first submission. We'll take a look here. Oh, very good job.
And that is the last time today I'll be ahead of Andrew.
Good job, good job. All right, so we're doing a little bit of a synchronization point here, making sure we don't have too many problems at once on the screen. There we go.
Turns out I don't know how to use group by.
Great job, folks. Amazing. Okay, then, on your mark, problem 2.
I haven't looked yet, but here we go.
All right. What's going through your mind?
So we don't like integers that mod 3 or 0 or have a 3 in their representation. And it looks like we are listing all of them that are good. The question is, output the kth element of this sequence.
Positive?
But k is quite small, so I think we can just count. So let's do that.
Very nice. So briefly recapping again. Yep. In this task, we have some numbers that are considered bad, specifically those that are divisible by 3 or that end in a 3. So you can imagine a list of good numbers, those that clear that specific definition. And our contestants have a specific index into that list of good numbers. And they need to reply with what the actual number is that's sitting at that index. Again, we can see some code that
sure does the job,
but I would probably not describe as idiomatic Kotlin. Don't write that in production code basis, please. It looks like we're coming up on the first submission over here. Good job, good job. Very nice, very nice. All right, time for a little bit of a code review. When you're not mutating a variable, please use val instead of r.
Unfortunately, all these variables are getting mutated here. How do I get a
The readline to int isn't being mutated.
How do I get an iterator over positive integers?
Sorry?
How do I get an iterator over all positive integers from 0 to infinity?
You can do parentheses and then 0 dot dot int dot max value.
Okay, int dot max value.
You can do long dot max value if you want more numbers.
Okay, dot fill
the what? The lost digit?
End with the digit 3.
Oh, is it?
Yeah.
Oh, interesting. Well, even so, I'm printing 13, which is quite, So I think I have another bug too, but let's see. Yeah, okay, so it's, okay, let's clean this up a bit here.
Is this
Spot,
more
spot the
idiomatic?
bug here. Has Andrew finished cleaning up his code? Oh, now we're good. Okay.
Does this work better? We don't believe in new lines here, so.
Is this still B, Andrew, or are we on C now?
No, I'm just trying
You're
to.
doing one line.
I'm trying to do this
Wonderful.
idiomatically.
You might wanna have-
idiomatically.
If you throw a .as sequence behind it, then it gets lazy evaluated.
As sequence.
Yeah.
Oh, these are list by default.
Yeah.
I see. I see. Okay. Okay, great. Okay.
Very good. And we even got to see a one-liner solution for the same problem, so that's very exciting.
Yes.
Great stuff.
On to C.
Okay.
If the one-liner passes.
Yeah, hopefully this passes. Should pass. We don't like variables here. Okay.
There you go.
Very nice.
Also takes
Amazing
600
job.
kilobytes. Okay.
Very cool.
Shall we start on C?
Okay,
Yeah.
time for Z. Let's
Yet
go.
Yet another keyboard with some missing letters. B is backspace.
The last, it deletes only the last lowercase letter.
Oh yeah, lowercase is interesting. And then uppercase B is the last uppercase one.
Okay, so what's the way to do this?
All right, so for whoever the description was too shortly up here on the screen, this one, our contestants have a sequence of key presses. Those are all letters. Two letters have a special function. We have the lowercase b that deletes the rightmost lowercase letter in the type string, and uppercase b that deletes the rightmost uppercase letter in the type string. So their program needs to process all those key presses and then output the string after all of those transformations were applied. Okay, we're seeing some mutable data structures on both screens here.
Okay, fine. Stacks. Mutable list to mutable pair int s star for each next. I see.
Let's quickly learn what this returns. Is this the last value or the last index?
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And you know, mathematics is really something that once you
Can I do this? I guess I can't. Okay. It's deprecated, but I think I can still do it. Remove at. Okay. Wonderful. Okay.
Yeah, now it's production ready. Let's just see that.
Oh, yeah, -1.
Yeah. How long could it be? CE. What? Compiler? Do you know was add last like newer? Is add last like newly added?
Probably just add?
I think it's
I
just
got a
add.
compilation error. Yeah.
I think for your next submission, you can change to Kotlin 2.2.
This is 2.2.
TLE. Oh, read the bounds. Okay. Yeah.
Weird. Interesting.
Yeah, I think you may have found a JDK bug, or well, a Kotlin JDK thing. That's a fun story for another time.
Release notes. Let's see if. Okay. Yep.
Yeah, so we have to do this very differently. Do we want to move on to the next problem? Because this would be a rewrite here in linear time. I want to store them separately and then remove them.
Yeah.
Probably not worth the time to write. Let's move on to D. What do you say?
There's a way you can do this in one pass. Well, it's kind of weird.
I would
Okay,
store
don't know.
I'd store the integers, but
Yeah.
what'd you do? What was your approach?
Yeah, I just stored two separate stacks and then re-interleaved them with like
Yeah.
a sort at the end.
Yeah, that's the way to go.
Yeah.
Doing it together is going to be unsquared, so
Yeah.
that's not the right approach. Okay, lesson learned, read the bounds.
All right, then we're moving on to problem D. We got both here. Great. Give it your best shot.
So we can remove any pair of adjacent characters any number of times, as long as the characters we remove are different.
Okay, this is. All right, let's try this again. S dot group by. Oh, grouping.
So, yeah, I guess the observation is it's always possible if there's no majority.
Okay. Any pair of adjacent letters.
So this one's 4, or no, this one would be 2. Yeah. Okay. I don't think we actually need to do it. We can just count.
So once again, in this problem, they're getting strings of lowercase letters, and when there's two letters next to each other that are different, then they can be removed from the string. So now our contestants need to determine how short they can actually make the input strings by applying these types of deletions. It's maybe interesting to note here that each string is up to 20,000 characters long, and they may receive up to 10,000 of those strings. Time limit is 1 second.
Is it max times 2 minus n.
Okay.
Very nice.
Okay. This is I learned this from the I learned the syntax from the Kotlin challenge thing.
Oh, very nice.
Yeah. Very good.
I have to say, it does look very elegant.
Yeah.
But very good usage of the Kotlin standard library here.
Yeah, each count. So what a crazy.
Grouping by an each count is a great combination for getting the...
Yeah, to get the frequencies.
Yes, exactly.
Yeah. Okay. One, two.
All right.
All right, you ready for the next?
All right,
Ready for
amazing
me?
job from both of you.
All right,
Here we go.
let's go. Eva.
Going into problem E.
So we have an array of n elements. F is the bitwise and of the range. And we have a bunch of queries. She wants to find the largest index R where the bitwise and is greater than k.
Interesting.
And it looks like we have 10 to the 5th of each.
Split. 2 int. So there's lots of ways of doing this. I think we're gonna do. Let's see. We can either do this with like some seg tree stuff or not. I guess I won't.
If we group them by L, then we have a monotonic queue.
Zeros.
And then we want to keep decreasing them. We'll have at
Dot
most
less than 30.
30 decreases,
0 until 30.
because everyone is a subset, so we shouldn't have any performance issues.
Dot.
So just to recap on this one, our contestants have arrays of numbers, and in each one of those, they're looking to determine info on the bitwise ands together of those numbers. Obviously, more numbers you add together, the fewer 1 bits you still have. So they get a start index, and they need to find out the largest index that they can pick so that the resulting ANDed together number is still larger than that lower bound that they need to clear, which is also part of their input.
Filter.
And
equals
yeah,
to
they don't do that once, they do that for many inputs.
Is there a map filter? Whatever, fine. Map index. V to I, B, V to I, or I to V, V,
There's a with index function, I think.
and 1. What's going on here? Infer, transform, to list.
Kotlin, unfortunately, we don't have these shift operators, yeah.
I can delete all this, right? Okay. The filter, it dot second. Dot first. Yuck. Equals 0. Okay. Repeat line but to int.
Okay. So then we want to go right to left. So that or for at in n minus 1 down to 0. Yeah, we have this query.
Zeros dot
Val.
So the largest index R such that this is greater than or equal to k, or negative 1. So let's see. Let's just we start off with 1 show 30 minus 1. 8 zeros. Oh, map.
Okay, so then I think we want to maintain, or I'm going to maintain a tree
Line to list.
set of values.
This dot next binary. L minus 1.
Yeah, so
Otherwise, the inverted insertion
I guess how does this work? So we'll have like,
var pos equals if pos greater than 0, pos else negative pos.
so on the right here,
Next
we'll initially have 1, 1, 0. Then we'll add 1, 1, 1 to this. And then,
one more element. Insertion point is this guy. Negative pos minus 1. Okay, so negative pos minus 1. If negative pos minus 1 equals random list. This dot lane.
I think we'll always have at most 30 of these, so maybe we just need an array.
Okay. Okay, great. Pause equals list dot binary search. Okay, so this is getting the next item, which is bigger than it. And then negative pos minus.
So this will just be
Yeah, negative
n
pos
minus 1.
equals list dot size. Okay. Binary search. Yep. Next. So this is like.
I guess we'll just have 0. Oh, but we need both the index
this
and the. That one has a pair, doesn't it?
Dot sorted by dot second. Okay. Char equals val. L minus. Char ans equals L minus 1. Oh, okay. Yeah. So val ans equals, I don't know, negative 1. Zeros dot for each. Val var v equals 1 shift left 30 minus 1. V XOR equals whatever, we'll do V2.
Okay, yeah, and then here, so
1 is shift left.
we also need to change everything.
If V is less than or equal to equals
Up is better?
x equals n.
Okay. Sorry, audio folks.
If n is less than n.
Okay, if we're a subset, we need to change everything's value in the start. We also need to merge things.
Yeah, n is the next bad one. Okay, so
If we're not a subset, then create a new value. If we're merging, we can probably always create that new value.
minus equals. If v is less than k, n equals idx, print line plus equals 1. If n equals l minus 1, else n minus 1. Okay, so index 2 out of bounds for length 1 at redis.get 13. So is this binary search returning the wrong thing? Negative insertion point minus 1. So minus pos minus 1. What's going wrong here? This is not supposed to be negated. Okay, so still array index 1 for length 1. N else. Yeah, well, I'm doing that, right? I think I'm handling that. This dot size. Position. What's going on here? What? What is happening? What? 0, 5.
What's my compile error here? Big integer. Is this bitwise and? All right, demo time. Here's the AI assistant in Kotlin. Do bitwise and in Kotlin.
19. Okay. It's a different line now.
ChatGPT is going to help me here. Oh, it is and. That's what I thought. Okay.
Wait, what? What is this?
So why do I have big integers here? This is a big integer.
Why am I doing a lookup in here? What? I'm so confused. What is going on?
Next val is an int.
What is
Second
type of zeros?
is an int.
Oh, it's not zeros. What? Okay, this is, okay.
So this is a
4b
list of paired
IDX.
ints. So why is
IDX
this a big integer? This is also an int.
All right, we're just gonna no time for variables. So
Okay. I don't know what that was about. Okay, so now I need to merge them. So merge adjacent equal pairs.
okay. Okay, so is this correct? This doesn't look very right. +1, right? Well, I'm also printing the wrong indices, so this is just completely wrong. Very good, very good, very good. So L ants equals L minus 1.
Okay. Then my logic says this should only have 31 things.
2, 6,
I
negative
hope.
1, 5. Okay. How bad is that? How bad could
Okay,
that be?
and this has to be sorted by L. And this needs a var ants equals 0. And then
Okay.
we need to print the answer. Okay, and then
Okay. Hopefully it's not all wrong. Okay, great. Yeah, okay. So, yeah, there are two main approaches to doing this problem, right? Are you
just
trying
get
to do
it?
it on a secretary?
oh no!
Really? Oh my. Okay, this is fine.
A little bit of drama on the final stretch here.
Okay. Okay. A dot scan reverse. Is it reversed? First dot scan n priv. From okay priv the scan indexed priv
Do you want
id
less than or equal to?
equals if v sure b and 1 equals 0.
Yeah, okay. Largest index, okay. So val ants will be first invalid dot first minus 1.
Reversed.
And then
N minus
sorted by
I.
L query index dot ants equals ants.
Yeah. Next, b plus t b 2 lst of L minus 1.
Dot.
So we're just gonna
okay.
kill the binary search by just
Can I?
storing the dense thing.
Oh, this is the index dot first.
Dot reversed. Dot scan initial
Yeah,
0.
okay. All right.
Best. So this is the index of the next 0, right?
So then here,
N minus 1
one
minus
query
I.
that's
also
that,
is
and we have an infinite loop.
Scan indexed is, oh, this is the wrong order. So it's I priv v.
Plus a space.
For input. What? Oh. Okay. Okay, seems better now. So the fix is to just use arrays and kill the binary search. Let's see if this is enough. Okay, seems to be correct, and hopefully it's a little faster. Okay.
You get it?
Yeah. Are you trying to do a seg tree?
What did you say?
Are you trying to do a seg tree?
No, I'm trying to do a sweep with a
I
monotonic
see.
array
Okay,
of
okay.
30 things, I think.
Right.
But I have an infinite loop somewhere. Probably
see.
here, I would guess.
Is there a way to break out of a for each?
You can label it with these things, right?
You can do what? Return?
Return at for each. With a labeled return.
And that will break, that will cause it to break out of the loop? Doesn't that just cause it to, isn't that continue?
Yeah.
Okay. For each with break. Let's see.
If you want to break, you can throw a label on like the outer whatever it is you want to do, and then I guess you can do a return after that.
Right. Return it for each break. Return at breaking. Okay. Run breaking at. Okay. Run is just like a block. Okay. Okay. Well, that's one thing I could do, but it's okay. Okay. Well, this is fine. Another thing we could do is like, we could just make this a return. Run hence equals run this thing.
Yeah, this isn't. I have an issue with my impossible case, which is, oh, I guess if the element itself is too small, then it's impossible.
Ideas.
So maybe it's not an issue.
Okay, so this should be equivalent, and it's like a little cleaner. It's like an IFE that we
Use some more of the functionality, sure. Now, Andrew, since obviously at this point you're just showing off, let me just chat with you for a moment. If David, you still want to give it a couple of minutes here.
Yeah, you have 2 more minutes.
Like, what was your perspective on the on this challenge here?
Yeah, it's pretty good. I think there's just like a lot of nice tools in like languages like with developed standard libraries like Kotlin. Kind of like C++ is kind of getting there with a lot of the ranges stuff, but there is just like a lot of nice things you can do with like these nice ranges and iterator libraries. And it's been pretty fun. Yeah. I think I'm still a little unfamiliar with all the like mapping and stuff and whatever, but and all the like mutable maps and whatever and how to use them properly. But it's overall I think it's pretty good.
How much Kotlin would you say you've written over the time?
I haven't written that much Kotlin. It's mostly just been for like Kotlin heroes and things like that.
Okay.
Yeah.
Sounds like you had a pretty good time picking it up. Then again, like I'm seeing a pretty decent use of the standard library functionality there.
Yeah.
Very exciting.
Yeah. I might be trying to stuff too much into too few lines, but it's okay. It's okay.
Especially in this context, I think that's perfectly fine.
Yeah.
Oh, wonderful. It's probably also a great reminder that, of course, if you also feel up to the task, that we do have the Kotlin Heroes practice round that's starting today, and then in 10 days we have the actual Kotlin Heroes contest that's also happening as well. And look at that.
Compilation error.
Yeah, the Codeforces Kotlin version seems a little bit out of date, but it is the most recent one, so I'm a little confused.
Sorry, let me make sure I pass samples here. It's like I've got like a minute left. 36 seconds.
35 seconds.
Okay, what would be the compilation? Let me just double check. Did I submit the right thing? I've already submitted it. Is there another Kotlin version, 2.2?
All right.
Let's take a look here.
Last minute AC would be
It's
clutch.
down to the wire.
Is there anything here that would cause compilation issues?
Okay. Oh, so you can click it on Codeforces.
Oh, can I?
Yeah.
It looks like another compilation.
Click the compilation error, the word compilation error.
Add first.
Yeah, I'm telling you, Codeforces for some reason doesn't have add first, add last. I don't know why.
Is there insert?
I think there's do add of 0, comma. Yeah.
Oh, but that's time.
Oh, that's time.
And it's dead. Oh no, we'll never know.
All right.
Huge round of applause, please, for our wonderful contestants.
There are fun problems, though.
Yeah, thank you so much for coming up here. This is really exciting. I mean, it takes guts, especially doing it in a language that you're not as familiar with. I think you did fantastically, given that context. So, yeah, that's really amazing. Let's wrap it up here. As a small thank you, and to remember Kotlin fondly by, of course, both of you can pick up the plushies that have been like guarding your laptops for this time. Thank you so much. We'll also still take a couple of pictures here in the middle, so if I could just ask you to come around. And once again, a big applause, please, for our 2 wonderful contestants.
Amazing. If you would like to talk to Andrew or David afterwards and would like to tell them what standard library functions in Kotlin they missed or how you would have approached it if you had been up here, they'll be around. So please come chat to them as well. And of course, please join any of the fun activities that we at JetBrains are organizing both here at the booth and at the Chill Zone as well. And thank you so much for being here. Appreciate it and good luck.